G'day guys, you know what time it is, another round of cheap crap from China. A bunch of packages today, so let's dive into them. First one's labelled PCBA. Don't believe I've got any PCBs assembled, but it's more breadboards. What a shock. Are they good ones or bad ones? I believe I ordered these because they were from the seller that sold me the good ones last time, but no, they're the bad ones. I've been through this before, but yeah, the numbers along the top here have absolutely no correlation to the tracks on the breadboard. Their internal construction sucks. These boxes are a dead giveaway. If you see these sort of in stores or for sale anywhere, do not buy. But oh well, they'll go on the shelf. They still work for basic sort of casual use, but you can get much better breadboards for the same price. Alright, moving right along then. Okay, so this is a cable I got for the CCTV cameras. As I mentioned, I've got about probably 5 or 6 of the cameras now that take a DC barrel jack and either give a BNC or RCA video signal. And this is just a simple lead to take one of the 12 volt DC barrel jacks and give you 4 outputs. Now I've actually ordered another one of these that's a 1 to 8 instead, which kind of just looks like a fire waiting to happen, but I'm going to need more than 4 outputs, and I really couldn't be bothered running multiple power packs. I'll probably end up running this off an old computer power supply anyway, so it'll have like at least 10 amps available, so there's no real drama with the actual available current, as well as I'm using those screw terminal adapters to the barrel jack, so I imagine those can handle quite a high current. It's pretty much only this wire, which as long as each individual output has its own wire, then I should be all good, even though the cameras don't draw much current anyway. But yeah, it should be right for a good few amps. Deluxe computer cable. Oh, how fancy. Black Ziploc bag. And what do we have here? It's a USB 3 extension cable. Comes with a little Velcro tie clip, handy. It's reasonably stiff, so yeah, I believe it's got at least some amount of conductors in there. Let's give it a quick test, shall we? So a nice simple power bank, and a big fat simple load. So the reason I got this was for the USB 3 hub on my desk, but also because I need a extension cable that can actually handle a bit of power. So USB 3, I don't think, well, obviously it's not USB-C or anything like that, so I don't think it actually has any decent current ratings, but what do we got here? Okay, so we're getting pretty solid output on the power bank there, 4.94 volts at 1.71 amps. So now let's measure it after the cable. And now we've got 4.75 or 4.8. Is that connector a little bit dicky? Seems okay. Alright, so we're dropping 0.2 of a volt across the cable. The current has dropped slightly, which Doesn't make a whole lot of sense. Wow, they get hot quick. But okay, it can handle 2 amps. So not the worst thing in the world. Yeah, I'll show you this thing as well because a few people have been asking about it. I got this USB hub primarily to act as a power supply. I wanted to plug this connector into, I've got a set of connections here which are directly from the 5-volt rail of a old ATX computer power supply on my desk. So if I plug this in, you should see, there we go, so 5.26 volts. So it's right on sort of the upper side, and it's like 5 volts plus 5%. So that is a solid power supply. It's got nice thick wiring going to the power supply. It's running over 5 volts, but within tolerance still. It's basically, yeah, a nice beefy supply. And so my idea was to be able to plug this into this and then have a distribution board to run, like to charge different devices or to run different circuits. Now, if I try with that same load, I'll switch it back to 1 amp. Plug it into here. So now we'll go with the most favorable port, the closest one to the cable. And the dickiness there, with this reading a bit low, the USB connector actually on this USB doctor device is a bit dodgy. So sometimes it'll make a bad connection, but it's now making a good connection. Okay, so the power supply voltage is dropped by 0.15 of a volt. That's actually more than I was expecting. And we're drawing about 640 milliamps. Okay. Now let's have a look at what this device is seeing. .8 or 3.9 volts. That's making, yep, that's making good connection at 3.9 volts. So it's dropping 1.1, 1.2 volts, which makes it completely useless, and that's only at 0.6 of an amp. Now, when I saw this, I thought, it must be the internals of this thing. It must just be a terribly designed PCB. Maybe I can run some jumper wires or something inside it to beef it up. No. If I apply the same power supply directly to the input side of this, it drops less than 0.1 of a volt across this entire unit. Through the switch, through the USB port, the PCB, the whole works. It is this cable. So this little stretch of cable is dropping 1.2 volts at 600 milliamps. I don't know what wire they've used inside it, the thinnest Chinese aluminium they could find, but yeah, that was very, very surprising. So I do still plan on taking the cable off that and putting a decent plug on the end. I'm basically still looking around for a good cable to hack up and sacrifice to upgrade that thing, but yeah, it was quite a disappointment. Oh, and another one. USB data cable. So this one is using the flat noodle type cable, I guess. Ah, so this is a USB-C cable. So it's a little bit more difficult for me to test. That's very interesting, the way that's sort of twisted to crimp onto the cable. That doesn't look like it's by design. That looks like someone's mangled it with a pair of pliers to make it fit. Interesting. Okay, well, I don't think I actually have a USB-C capable load, at least not one that I can easily hook up and demonstrate, so I'll have to put this one in the pile for later. I do have my 35 watt adjustable load, which it does have a USB-C port, but yeah, that's a whole thing I have to hook up and run software on my computer to tell it how much load to draw and whatnot, so I'll do that in a separate clip. And this one contains a whole bunch of step-down regulator modules. Now, I've used these a lot, so I figured I'd buy a few more to stock up. These are by far the best low voltage step-down modules I've found on the market. They are very, very surprising. I'll see if I can get some better focus on it there so that you can see it. Okay, so simple enough design, plus and minus in, plus and minus out. Decent size inductor. It's a fairly low value inductor, but that's not necessarily a problem because this little chip on it is an MP1584, which has quickly become my favorite. It has a very low quiescent current. It only draws, I think, about 20 microamps if you're not drawing any load, and then if you are drawing load, it draws sort of a couple of % off the top of your load. And it switches at up to 1.5 megahertz. So very, very high frequency for a switching power supply. So that's why it only needs a fairly low value inductor. And so this little board will handle a maximum input, I think, of 28 volts and give you a regulated output down to 1 volt. So they're very commonly, most of the time we'll end up using these for 3.3 volt or 5 volt outputs. There's a little carbon trimmer. Again, focus doesn't like me. But yeah, there's a little carbon trim pot there to adjust the voltage, and so you literally just will hook it up to a supply power and then put a meter across the output and adjust that until it's at the voltage that you want. And so they'll happily step down 24 volts, 12 volts, 5 volts, whatever, down to 3.3 volts or 5 volts or whatever you want. They can only go down, and it has a minimum voltage drop, I think, of only like 0.15 volts. So you can use it on, say, a lithium battery driving a 3.3 volt device. It means that when the battery falls below 3.3 volts, you'll get lower voltage going to the device, but down to the battery, like if the battery's at about 3 volts and it's pretty much empty, and in that case your circuit will still be getting 2.85 volts, which is about the sort of lower limit of what 3.3 volt circuitry will normally run at. So they're pretty much ideal for running lithium battery circuits as well. The other thing with them is they will cut off their output if the input voltage gets too low. They're meant to be a minimum 4.5 volt input, but they will continue to run down to about 2.8 or 3 volts, and then they'll cut themselves off and cut the load off. So because of that, again, they're very, very good for lithium battery circuits. Of course, you should always have a protection circuit in line. One of the I often use the TP4056 modules that have a DW01 on board with them, and so that gives you your under voltage, over voltage protection, as well as a USB charger, all in the one little board. So you should always have one of those in your circuit anyway if you're designing your circuit to take a lithium battery, but if you're using one of these, you can get away without having that, and just directly power your circuit from a battery using that module to step down the voltage. Okay, nothing exciting with this one. Vape coils. I've shown you various vape wire in previous videos. These are just the pre-made coils. Save time, save stuffing around. And I've got a lot of tanks that these work with, so stocking up on those. For those that are interested in vaping or such, I get this sort of pack of 20. There's 5 in each box. And that set will usually last me about 3 months. So that's a good indication of just sort of how frequently you need to go through the coils or whatever. Australian dollars, I think that's $35 for that set. So they're a bit over $2, a bit under $2 each. And so yeah, each one of those will last about a week, which isn't bad at all. I was paying $45 a pack for cigarettes and going through a pack every 2 days. Now I go through a bottle of juice, which costs $6 once a month, and one coil, which costs about $1.50 a week. So all up, it's something, yeah, very, very low. What is that, maybe sort of a bit under $15 a month compared to $45 every 2 days. It's absolutely ludicrous how much cheaper it is. Okay, another one for the adapter set. These are a bit of a weird one, but I noticed I didn't have anything that could do this sort of task, which is to convert a male BNC to a male BNC. So I have a lot of adapters from like male RCA to male BNC, and from female RCA to male BNC. So if I want to make sort of an RCA gender changer, like a female to female one, I rather than keep every possible combination in stock, I've set myself up to adapt everything to BNC, and now I can use these to sort of go in the middle to create an anything to anything adapter, just as needed. So just a bunch of those. They were $2 or $3 from China. Okay, and that's everything for right now. I believe I have another couple of packages coming in later today. If they do arrive, I'll add some more onto the end of this, but otherwise, thanks for watching, and I'll see you next time.